Hi guys, in this video we are going to discuss about what's meant by the resonance series circuit. If you are new to this expert tutor channel, please consider subscribing. Also, we have done many videos regarding electrical fundamentals theories. If you like to watch them, I have given the link in the description so you can always watch them. Okay, without wasting our time, let's move to the main part. Over here you can see that there are three elements which are connected in the series. So from that, first of all, we need to know what's meant by the resonance series. What's meant by the resonance or when it happens. So the simple thing is, when the impedance or the reactance part is getting zero in this circuit, which simply means it's going to be when the omega L minus 1 over omega C is equals to 0, the reactance part is going to be 0. We are going to tell that situation as resonance. So the thing is, you need to remember the resonance will be happen when omega L is equals to 1 over omega C. So when these two are equal, you can directly tell it's going to be the resonance series circuit. So this is the main idea of resonance. So what will happen when the circuit is in the resonance? Yes, we can discuss it further in the next video. However, in this video we are going to discuss a question how to find the omega R and FR and these values when that series in the resonance series circuit is in the resonance. So the simple equation you need to memorize is, it would be the resonance would be happening in that series circuit when this omega L is equals to 1 over omega C, which simply means the reactance part of that circuit, even though there are inductance and the capacitance, the reaction part is going to be the 0. So the first question is, they are asking about to find omega R and FR, which simply means we need to find the angular frequency of that of that circuit when that is in the resonance. Likewise, we need to find the frequency of that circuit when it's in the resonance. So actually we already discussed that equation. We are going to use this equation, which simply means omega L minus 1 over omega C is going to be 0. So this omega would be omega R when this circuit is in the resonance. So from that we can directly tell, actually we knew the value of L, which simply means it's going to be 100 microhenry and the capacitance would be 0.01. So sorry, this is millihenry, it's going to be microfarad. So from that we can, if I rearrange this, we can directly tell omega R would be equals to 1 over root LC. You can directly use this equation too. However, we have derived this from this part when omega L equals to 1 over omega C. If we subject that omega, we are going to get this equation. So the next part is, we are going to substitute the value of L and C over here. If we substitute these two, we are going to get L like this one, 100 milli means 10 to the power minus 3 into capacitance would be 0.01 into 10 to the power minus 6. So if you simplify this, you are going to get the resonance angular frequency is going to be 3.162 into 10 to the power 4 radian per second. From this one, you can directly find the F, the frequency at that resonance series circuit would be omega is equals to 2 pi F. You can directly tell omega R over 2 pi. If you simplify these two, you are going to get the frequency of in that resonance time. It's going to be 5030 Hertz. So now we have found these two values. The next question they are asking is, find the magnitude of VR, VC and VL at resonance. So how to find this one? Actually, they haven't mentioned about the current, I think. Yes, they haven't mentioned about the current for this circuit. However, we knew the value of omega as well as L and C as well as R. So how to use these four to find the current, and from that we are going to find the voltage difference across each element. So we can directly use that. So the first part is, actually when we don't know the current value, we need to find the total impedance of this part, the series, these three elements. After that, we can directly derive the current using B is equals to IZ. So the first main thing is we are going to find the Z of these three elements, the impedance. Actually, we knew that if there are elements connected in a series, we can directly tell that Z equivalent would be ZR plus ZL plus ZC, which simply means we are going to add up all impedance, each impedance in these elements. So ZR plus ZL plus ZC. After that, I am going to substitute. If you substitute these values, you will be getting an answer. It's going to be ZR, which is equals to 10 ohms plus, actually we knew that ZL plus ZC would be 0 because we knew that omega L minus 1 over omega C into G. The real part is going to be the R, and ZL plus ZC would be this one. Actually, we knew that when there is a resonance, we can directly tell it's going to be 0. From that, we can tell the Z equivalent would be 10. So our question is going to be very simple. If you know the value of Z, we can figure the value of current using the Ohm's equation. B is equal to IZ. From that, we can tell I is going to be equals to V over Z, which is 50 over 10. Be remind that as these are really nearly like to a full resistance, a pure resistor, it's going to act like pure resistor. So we can consider as 0 and 0. Actually, there are no complex numbers, there are no inductive characteristic or capacity. Because they are 0, they are going to give a resultant of 0. So we can consider like this, and it's going to be written the value of 5 ampere. Now we have found the value of current. From that, the next step is we need to use the Ohm's equation for these three elements individually, and we need to find the VR, VC and VL. So let's use this one. VR is going to be equals to I into XR. From that, we already knew the value of I is going to be 5 at 0 angle, phase angle, and the XR would be, we can directly tell it's going to be the 10 with the phase angle of 0. If we multiply this, 5 into 10 is going to be 50, and if we add these two angles, it's going to give 0 phase. Likewise, we need to find the VL. VL would be I into XL. Actually, we knew the value of I. You can directly write it like this: I with the phase angle 0, and the XL. What the phase angle of XL is, you need to remember. If you knew the value of I, it's in this direction. Actually, we are taking that I in this direction. I, when we are considering about the voltage, it's going to lead. If I consider any inductor, the voltage of that inductor would lead that current by 90 degrees, which simply means it's going to lead. So this would be the voltage. So from that, we can directly tell it's going to be XL would be V over I, which simply means it's going to be at the 90 degree, and the XL would be, actually we knew the value of XL there, we need to figure it out. It's going to be omega into L. Omega we knew the value of omega we knew the value of 3.162, and after that we need to substitute the L, which is 100 millihenry. If we substitute and if we simplify this, we are going to get the value 15.81 kilovolt. But be careful, it's going to have the phase angle of 90 degree. So however, if they haven't asked about that phase angle or in the polar form, you don't need to write these things. However, it's better to write or to give these values. So you need to add these two, and we need to figure this value, the omega L, and we need to multiply these two and put over here. Likewise, you can directly find it for VC. It's going to be equal to 15.81, because actually we knew that omega L is equal to 1 over omega C. However, the phase angle would be minus 90. So be careful with that. The C would be 15.81 kilovolt, but in the negative sign, which simply means it's going to be minus 90. So the main part over here we have studied over here is, actually when there is a resonance, at the series circuit, you can directly use that the omega L would be equals to 1 over omega C. Thank you for watching.